Hey, Sam here. We're going to do another Leetcode question. We'll do an easy one in the algorithm space. So let's set that up. And I'm going to start a timer as well. So let's just pick one at random and see what we get. Ooh, this looks kind of fun. Number 953, verifying an alien dictionary. If you probably noticed on the right side, I have this horrible thing called a Google Doc, and we're going to use this. And the reason for that is sometimes you only get access to a notepad or doc to do your your actual interviews when you're interviewing with a company. This is kind of like using a whiteboard. Everything's online most of the time nowadays. So whether it's an entry-level position and you're just trying to get your foot past the door, you might be given a notepad kind of doc to do all your coding on. And the worst thing that happens is you've gotten really used to using something like Leetcode's IDE or your own IDE, and you don't have access to any of that, and you can't remember how to do a certain function call or space. Like, I know it's completely pointless that we have to use docs instead of IDEs, when in real life you're almost always going to use an IDE, but that is how real interviews sometimes are. So just get a little bit used to it. Once you get used to it, it's not too hard to deal with, and hopefully once you have your job, you don't have to deal with that ever again. So let's have a look at what we get. Verifying an alien dictionary in the alien language, which happens to be lowercase English letters, thank goodness, but possibly in a different order. Oh, this is kind of cryptography. This is kind of fun. So the order of the alphabet is some permutation or reordering of the lowercase letters. Given a sequence of words written in this alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in this alien language. What does that mean? Words hello in Leetcode. The order is that and output true, and that is because H comes before L in this language, so then the sequence is sorted. Interesting. So we're given multiple words, and we want to make sure that the words are in order in this alien language. So if there was no alien language and this was English words, we're just trying to make sure that all the words are given in a sorted order or not. So that's kind of cool. So for example 2, word, world, and row, given this alphabet, it's false because D comes after L in this language, because W is one of the first letters in the alphabet. So word 0 is greater than words 1 because the D of word comes before the L of world. Okay. So one way we could think about this is, if this was English, we're checking that all words are given, that this input words are sorted. That's kind of what they're asking for here, but because of this alien language thing, we have to check first based off of the alphabet that they give us. So apple and app, the first 3 characters match, but the second string is shorter in size. So according to the lexicographical rules, L comes before 0. It's the blank character, which is less than any other. All right, so that stays true even with English, so we don't need to do anything special. So one of the first things you could check for is whether the size of the words is increasing versus decreasing. So if there's ever a word that comes that's shorter than the word before it, then we've already failed. So ever comes longer than the previous word, we failed. Output false. That's kind of one edge case. If there's only a single word in the words, then it's always true. Okay. The input sequence of words is not sorted. Well, it is sorted when it's true, but we have to check every single one. So no matter what, we have to check every single word. So we have O of N for N words. That's our perfect no matter what. So we can never do better than that because we have to check every single word. On average case, we might do a lot better, because if most of them are failing early on, then we would be ending as soon as we have a failure. So on average, it would be half the size of the O of N over 2, I guess, for not O, omega, I think is for average case. Either way, unimportant here, but good to talk about out loud when you're doing it in an interview, just so your interviewer understands that you're thinking about these things. At least I think so. All right, okay. How do we go about checking whether the words are sorted lexicographically in the order of this alien language? So one way you could do this, and I'm not saying this is the right way, approach one is convert alien words to English. Change each letter based on alphabet. Then just check if words are sorted or not. And you could do this. I think this would be a lot of extra work, and in the ugliest way to do that is check if words is equal to sorted of words. This is shortest amount of like words written, but would be a lot of extra work, so we're not going to do that, and it's not even close to algorithmically efficient, I think, because there's no point in sorting all the words if you know that the moment you have one change that is wrong, then you have already failed. So instead, we're going to think about approach 2. Let's see how can we do this. What we'd like to do is for each word, if it's greater than the previous word in alien lexicography. And if it is, keep going. Return false on fail. At the end, return true because it all passed. That's kind of the main approach we're trying to do here. And so let's create this let's just call this magical function like alien greater. And it's going to take in word 1, word 2, and returns a bool of true or false based on whether it's greater or less than the previous word based on this lexicography. We haven't created this function yet, but let's pretend it exists. So we have our main, let's call this main, they've actually given it to us here, is alien sorted. And our input is going to be a list of strings. So it'll be called words, and we'll do list of string. And our output is going to be a Boolean that tells whether or not it is. And so let's say we have this function that exists, and what we'd like to do is for I in range 1 through the length of words. And the reason I chose 1 is because we want to use the word as well. So word 1 is equal to words of I minus 1. And word 2 is equal to words of I. And then if not, if alien word, if word 1 is greater than word 2, then we have the wrong order. So we return false because we failed here. Otherwise, we continue and return true at the end. That would be our general function, is kind of the goal here. In fact, they give us words as well as order, so let's keep that as well. An order will be a string, and that is we want to double check, but is it always guaranteed to give us exactly 26 characters? And I think the answer is yes. In fact, they also tell us that the length of words is not greater than 20 and not more than 100 words, and they're always going to be at least 1 character long and at least 1 word is given. Okay, so in this case, if the length of words, if there's only 1 word, this loop would never happen. It would just return true by default, because for a single word, that's always true. Okay, this is actually not too bad. This is fine. So how would we go about checking if alien greater? How would this work? So let's say we have our lexicograph given to us, and this will be a string. These will all be a string. Like that. What we'd like to do is character by character first check if the length of word 1 is greater than word 2, length of word 2. then it's not. Oh wait, no, it could be, because if this is not true, because cat is going to be greater than carb, even though it has fewer characters, because the T is greater than the R. So we can't actually do that. So actually earlier when I was saying that you could check by the length of the strings, I was actually incorrect about that. So sorry, you may have heard me say that and you were calling it out. I finally got there. All right, we're about 10 minutes in, and I think we're at the meat of it now. How do you compare words given this word ordering? I guess one way is you could check for each character, for each index, compare characters' position in order. That's one way you could do this. And if the position ordering is correct, then you're good to go. Otherwise, you return false when it's not the case. Yeah, so I think that would probably be the... You can either try to... So that is one way to do it. But for example, let's say word one is cat. You look it up in your ordering. Let's say this is the ordering here. So you look up the C and it says 0, 1, 2, 0, 1, 2, 3, 4. So the first letter C is to 4 and there, and then you compare to carbs, C is to 4 and they're equal. So you keep going. Let's pretend it actually had been DAG or something like that. Then the D is a 5. So let's say D is 5. So now you've proven that the word 1 is not greater than word 2, so we'd return false in that case. Otherwise, if it was the other way around, we'd return true. And then you have the special case of if one of them is shorter the length than the other, you return true or false based off of that. So actually, I think that works just fine. However, how do you find your position inside this ordering? You can either do what I just did where you count your way through it. That's O of K for the length of order. You could also create a mapping of order by its index, which I think I'd like to do. So order map equals, let's do it here actually. For I char in enumerate order. And I think you can just apply this to a string. It'll iterate through the characters of the string. And we want to take that character and its index as the key mapping. And that'll just create a dictionary of like say ABC yields A is 0, B is 1, C is 2, kind of like that. And now when we want to get the index of the order map, we can just use this order map instead. And I'd like to do that. Order map is a dict, and our input is string, and output is int index. Okay, that'll make it a little bit easier because now it becomes an O of 1 type approach rather than O of K for the length of order, and which is also O of 1 for order being a fixed size of 26. This just feels a little cleaner and scales better. Okay. So for I in range, the max of the length of word 1, word 2, length of word 1 and length of word 2. This is one of those cases where having an IDE would be very nice because you need to figure out how many parentheses you need to close it, and you unfortunately don't have it. It's not critical when you're in an interview to get these syntax things right, but I'm going to be copying it over to Leetcode in a minute, so I still need to. All right, so we're iterating through every character in both words, and the moment we have a failure of one of the words, has no more characters will be breaking out. So first we check if I is greater than word So here let's actually do it in English. So if word 1, if we reach the end of word 1, but not word 2, return false, because we have now got a smaller word 1 than word 2. If reached end of word 2, but not word 1, return true, because everything matched up until this point and the second word is larger. Now if both of them exist, then we continue on by checking if position of word 1 char greater than word 2 char, return true. If position of word 2 char is greater than word 1 char, return false. Otherwise we continue. This is kind of all the steps all the cases we need to check for. There's going to be a way to simplify this. Not entirely sure yet how. Since this is a one-to-one mapping of the alien language, we can kind of check whether the characters are the same or not straight away. So let's see. Character 1 is equal to word 1 of I if the I is less than the length of word 1. -1, else none. And similarly for C2, we do that for the second word. And now we can check if we reach the end of word 1, if not C1 and C2, return false. Else if C1 and not C2, return true. Then we want to check if the position of the word 1 char is versus word 2 char. So we can say position 1 is equal to order map of that, and similarly P2 is equal to order map C2. So if P1 equals P2, we just continue. I don't think we actually even need to check that because it'll happen by default in the for loop. So let's just say if position of word 1 char is greater than P2, return true. Else if P2 is greater than P1. Actually, I think it'll be a little nicer if we do it the way we were talking about first. So we'll continue if P1 is equal to P2. Otherwise, we'll just return P1 greater than P2. It'll be true if the first word character is greater than the second. Otherwise, it'll be false. And if they're the same, we're going to continue through this loop because they're the same character. So we can actually do that here before we even check. we'll just use the characters themselves because it doesn't matter. The mapping will be the same for the two words. And then we don't need to even store that. That'll just shorten it a little bit. Okay. So another thing, so we don't need to worry about the case where both C1 and C2 are none, because we'll never get an I like that, because we're only going up until the max length of both of those words. And in fact, that means we don't need to do this double not thing. Yeah, we can simplify this a little bit more. So first check is if we've reached the end of word 1, we return false because we're iterating over here. Similarly, if we get here, return true because we reached the end of word 2 but not word 1. And these guys can be set directly with a lot simpler logic right here, and we don't need to do these two checks anymore. There we go. Yeah, okay. Spent a bit of time on that actually, sorry about that, but just trying to logic my way through it all. And let's think a quick bit about the big O for this. First of all, we're doing a iteration over the number of characters, so O of k for k char, longest word. We're doing checks within the dictionary. These are O of 1 checks, and we're not storing anything extra within this function itself. This building of the map is O of n, or O of k, actually O of k approaches 1, time and space for building order map. Because we have a fixed size order map, it's only ever going to be 26 characters. Similarly, the dictionary will only have 26 keys and values for the indices. This iterates O of n for n words, and doing this check is O of k for the k characters in the words, so we get so our final result is going to be O of kn time and O of k O of 1 space for this approach. And I think this is the best we can ever do because, as we were saying earlier, for n words, and actually this is O of kn for k length words, because we have to check every character of every word to make sure that they're sorted in the perfect case where you have everything's exactly right until the end. Yeah. Okay. Well, let's try putting this in and seeing what we get. So this function will be a subfunction, and There we go. Yeah, it'll only continue if the characters are the same. Otherwise, it will return whether they're different or not. And then down here, we have our main function. I think one other thing that's kind of interesting, this feels quite a bit more complicated than it needed to be. So let's see if we can make this simpler in a little bit. But first, we have our order map. We have our words, and return false if they're ever in the wrong order when we're iterating through this. Okay. Well, let's have a look and see what we get. Ooh, runtime error. Oh, did I? I expected a colon. Did I miss a colon in here? 1 second. Oh yeah. Whoops. A little bit of a typo. And I missed parentheses. The trials and tribulations of using a Google Doc. Ooh, all right, so we have a wrong ordering here. Return true instead of false. So what's going on? Word, world, row. So I was expecting it to return false once it hit the first two words, because D comes before, or L comes before D in this ordering. So what I'm trying to look at here is to make sure I'm actually getting the right order map. I would expect that order map of the letter D here, for example, versus L will return 0, 1, 2, 3, 4 versus 3. So the first one would be a 4, and the second one would be a 3. So that would end up with being true here. And so that would say that word 1 is greater than word 2, which is wrong, true. So if that's true, it returns false. Which is what should have happened, but instead it passed, which meant it did it incorrectly here. Oh, no, word 1 and word 2. I'm wondering if there's going to be some little typo in here where I put word 1 twice instead of word 2 or something like that. C1, C2. I don't see it yet. If you guys are seeing this and you're yelling out, sorry about that ahead of time, but here we are. So word 1, word 2, passed in word 1, word 2, words 1, word 2. They're two different things. We created our order map. And we're passing in C1 and C2, and they're word 1 and word 2. In the case that they're both the same length, and they're exactly the same, we do have a case. One thing I'd missed here is if they were exactly the same, then we return false. Is that because they're not greater than? And similarly here, apple and app return true instead of false. Let's just do a check and see if this was actually the thing. No, I didn't think so. Alright, what do we got going on here then? We've reached the end of word. So the issue with this one at least is that we're returning true instead of false, which means alien greater is always false, which means we're returning false incorrectly at some point. One of the cases where we return false is if the first word is smaller than I. Oh, if I is less than the length of word, it's not, if it's greater than, sorry. If it's greater than or equal to, you guys may have been seeing this from the get-go, that was the main issue here. If we reach the end, to reach the end, we're not checking if it's less than the end. That was the mistake I was making. So once we've reached the length of the word, that means we reached the end of it. Oh, this is a lot cleaner. Sorry about that. Okay, let's try this and see how we're looking now. I would expect us to actually iterate through the word. And it seems to be the case. It's passing all three of the test cases. And let's try submission and see how we do. And it was accepted. All right, that's good to see. Wow, this was a surprisingly tough one for me today. But sometimes that happens. And at least we were able to talk it out and see what we got. Let's see if we can clean this up a little bit. I'm going to go ahead and make sure I change it over here to just so we don't forget. And length of word too. So what could we do to make this cleaner? I think there's probably a few things. I think we don't need to use the C1, C2. There's potential for confusion with that. Now we're using the character inside there. These, I don't know if I'd call that cleaner, but it is a bit shorter and less likely to have a misspelling of the words. I'd like to somehow kill these or even these. Okay. Oops, I accidentally ran it again. Keep forgetting whatever that shortcut is that does that. Shift enter maybe? Let's see. Nope. Control enter? Yeah, it's control enter. All right. Well, maybe there's some other things in there. Let's see if there's anything I'm missing from some of the other solutions. Here's one of the more common ones. They use order of the index. So this is technically, this is probably optimized under the C hood, but you're doing a iterative search through the whole thing every single time. And, it's good to be able to do that, but this is where you need to be able to talk it out with the interviewer, where these sort of optimizations, in this case was, let's call it a premature optimization because it may slow down the solution here. And so therefore you didn't need to do it in the first place. But the advantage of this is that you are doing O1 searches when you're checking for the word index inside of the order of the lexicographic alphabet. You don't have to do that. You could do something along the lines of order.index of word 1 of I, and this would get you the same index value, but it would be doing a O of K search each time for K order. So that's a bit of extra work. In this case, it's not important, but being able to explain to your interviewer, like, it's actually totally fine to use this if you want with your interviewer, but you need to be able to explain why you're doing it and why that might be, when there's an alternative of, like, say, building a hash map here, why you would choose one over the other. Trying to think of any other useful tips, tidbits, but for now, this is where we are. And hopefully this was interesting to all of you, and I'll see you guys next time.